Morning students, today we are going to discuss about generator, the DC generator and the various types of DC generator, and also at last we are going to discuss about the applications of the various types of DC generator, right? So first we are going to discuss about the generator. So I hope you understand that what is meant by generator. So a generator is nothing but an electrical machine which converts mechanical energy into an electrical energy, right? So the mechanical energy will be given in terms of the help of some prime mover like steam turbine or hydro turbine, etc., etc., right? Suppose if we given mechanical energy, the output of a generator will be an electrical energy, right? So based on this, we are having two types of generators. One is called as an AC generators, or it is also called as an alternators, and the second one is called as a DC generator. Suppose if you give an input energy as a mechanical energy and the output energy is nothing but the AC electrical energy, that is called as an alternator or AC generator. Suppose if we give a mechanical energy as an input and the output is nothing but the DC voltage, then that type of generator is called as a DC generator. So the main difference between an AC generators and the DC generators is nothing but in case of an DC generators we will have a commutator, right? So it is a main important device which converts an alternating quantity into a direct quantity with the loader. So in that first, in case of an DC generator, as per the DC generator is concerned, mainly we are having two types of DC generator. One is called as a separately excited DC generator. Separately excited DC generator. The second one is called as a self-excited DC generator. Self-excited DC generator. Okay. Suppose if we take a DC generator, mainly we have two parts. One is nothing but the armature part, whereas the second one is nothing but the field part. So in case of a DC generator, we are saying as an armature is nothing but the rotating part, that is the rotor of a DC generator is nothing but the armature winding, whereas the stator of a DC generator is nothing but the field winding. So it is nothing but the stator part, right? So these are the main two important parts in case of a DC generator. One is nothing but the armature, which is a rotating part of a DC generator, and the second one is called as a field winding, which is nothing but the stationary part of a DC generator, right? So based on this field excitation, the DC generator is broadly classified into two types. One is nothing but the separately excited DC generator, and the second one is nothing but the self-excited DC generator, right? Suppose if we take so this is a symbolic representation of a generator. So we are having so this is nothing but the armature, so that is an A1 and A2, and this is nothing but the field one, which can be represented as an F1 and these two are the main important part of a DC generator, right? So based on the excitation given to the field winding of a generator, it is classified into two types. One is nothing but the separately excited DC generator, and the second one is nothing but the self-excited DC generator, right? So in case of a separately excited, from the name itself it is concluded that the excitation to the field winding of a DC generator given with the help of an external source. It means that we need to connect an external DC source to the field winding of a generator, so that there will be the flow of current in the field winding, which will produce the flux. That flux is called as a field flux, right? So this flux is responsible for the action of a DC generator. And the second one is called as a self-excited DC generator. It means that in case of a self-excited DC generator, the excitation to the field winding will be given with the help of the generator itself. So this type of generator is called as a self-excited generator. So in case of a self-excited generator, so we are having a generator. So we will have an armature winding, and then we are having a field winding. It means that the field winding of a DC generator will be excited with the help of its own generator, own generator itself. That's why it is called as a self-excited DC generator. But in case of a separately excited DC generator, the excitation to the field winding will be given with the help of an external source, right? So this is the main difference between the self-excited and the separately excited DC generator, right? So in case of a self-excited DC generator, two important points is very important. One is nothing but the residual magnetism. Residual magnetism Second one is called as a residual flux. Third one is called as a residual voltage. These three concepts are very important with respect to the self-excited DC generator. Because what we have already discussed, that self-excited DC generator is nothing but the field of a generator will be excited by its own, right? So how the field of a generator is excited at its own? It means that at the time of starting there will be no output from the generator. Then how the field will be getting excited? It means that, so that is the help of the concept called as a residual magnetism. It means that there will be the field winding in a generator, okay, so which will have its own property, that is called as a residual property. It means that without giving any excitation to the field winding of a generator, the field will have its own magnetism. That concept is called as a residual magnetism. Due to that residual magnetism, what will happen in the sense, the residual flux will be produced in the DC generator. Due to that residual flux, there is a small amount of voltage will be generated, that is called as a residual voltage. So this residual voltage will be given as an excitation to the field winding at the starting point. So at the starting of the self-excited generator, the build-up of an voltage will be very low. Once the generator starts build-upping, then the high voltage will be given to the field excitation. That way, at the end, we can able to have the rated voltage at the output of the generator. So this is a working of a self-excited generator, right? So it means that we are having three properties: residual magnetism, residual flux, and residual voltage. At the time of the starting, the field excitation will be given only of the voltage level of a residual voltage. Then the voltage will be built up in a smaller manner until the output of the generator voltage is getting as a rated voltage. This is a working of a self-excited generator. Based on these types of a connection of a field, the self-excited generator is classified into three types. So the first type of self-excited generator is called as a shunt generator. Shunt generator. So it is classified, the self-excited generator is classified into three types. One is a shunt, second one is nothing but the series, and the third one is nothing but the compound. This classification is based on the type of connection, means that the type of field winding is connected with respect to the armature. So first we are going to discuss about what is meant by shunt generator. So we already know that shunt is nothing but the parallel. It means that if the field winding is connected in parallel to the armature winding, then we can say that type of generator is called as a shunt generator. So this is a graphical representation of the shunt generator. So here I am having an armature winding A1 and A2, and then I am having a field winding. So F1 and F2 represents the field winding, and the output of an voltage is nothing but the terminal voltage Vt. If we connect any load here, in the sense, then that will be the flow of current called as a load current. It means that we are connecting load across the terminal voltage. So the current flowing through the armature is nothing but the armature current. Current flowing through the field winding, shunt field winding is represented as an ISH, whereas the current flowing through the load is nothing but the load current. Here RSH represents the resistance of the shunt field winding. Why it is called as a shunt generator in the sense? Because the field winding of a DC generator is connected in parallel to the armature winding. So this type of connection leads to a shunt generator. So the voltage equation of a shunt generator can be written as, so this is nothing but the EG. EG is nothing but the voltage generated at the armature. So the generated voltage EG is equal to terminal voltage plus the losses in the generator. So what are the losses occurs in the generator? Here we are having an armature. Armature is nothing but the, right, so it will have its own resistance which can be represented as an RA. So definitely there will be the drop called as an IA RA drop will be there. Then we are having the two brushes. So there will be the drop on the brush which can be represented as an V plus. So this is an voltage equation of the shunt generator. And also the armature current IA can be written as IA is equal to shunt field current plus load current. So armature current is divided into two, shunt field current and the load current.